This question is from GATE 2016 Mechanical Engineering Paper Set 1, question number 11. A single degree of freedom spring mass system with viscous damping has a spring constant of 10 kN per meter. The system is excited by a sinusoidal force of amplitude 100 Newton. If the damping factor or ratio is 0.25, the amplitude of steady state oscillation at resonance is dash millimeters. I'll start by writing the given things. The spring constant K is given as 10 kN per meter. Amplitude of force is given as 100 Newton. It is sinusoidal in nature, so we can write the force F is 100 Newton, its amplitude into sine omega t, where omega is the frequency of the force and t is time. Also, damping ratio is given zeta, which is 0.25, and we have to find the steady state oscillation amplitude at resonance. So we can write the condition at resonance. Forcing frequency omega becomes equal to the natural frequency of the system, omega n. And therefore, the ratio omega by omega n is 1. Now, in order to find out the amplitude of steady state oscillation, we use the formula x equal to f naught by k upon root over 1 minus omega by omega n square whole square of this term plus 2 zeta omega by omega n whole square. This formula you should know beforehand to solve this problem. Now let's substitute the values here and find out amplitude. F naught is 100 Newton by K is 10 kilonewton per meter. So we have to convert it in Newton per meter. It is 10 into 10 to the power 3 Newton per meter divided by root over. This first term is 1 minus omega by omega n is 1. So the first term becomes 0 and 0 square is again 0. So we have 0 plus. This second term is 2 zeta omega by omega n, which is 1 whole square. So we have 2 zeta whole square, that is nothing but 2 into 0.25 whole square, which is equal to. The numerator turns out to be 1 by 100 divided by under root of this term square. So we only have this term left in the denominator, that is 2 into 0.25, which is simply 0.5. 0.5 is 1 by 2. So our answer is 2 by 100. Now this answer is in meter. So we have to convert it in millimeters. We have to write the answer in millimeters. So just multiplying this with 10 to the power 3, we have 20 millimeters is the amplitude of response at resonance. Let me go back and fill in the answer. So amplitude of steady state oscillation at resonance is 20 millimeters. To learn more about amplitude of vibration, you can refer to the NPTEL video Module 2 Lecture 12 L12 Vibration Isolation, Vibrations Measuring Instruments from the course Soil Dynamics. This course is by Dr. Dipankar Chaudhary. He is from Department of Civil Engineering of IIT Bombay. I hope this solution will help you clear your doubt. Thank you.